So do any yeah. So do any of you have any questions or like specific question you guys want to go over?
Oh, someone has their hand raised.
Yeah, Joseph.
Hi guys. I was hoping for just a few examples of the runtime analysis for recursive functions.
Okay.
Sure. Do you have any specific problems that you would like to go over from that? Maybe from homework
Oh,
or
yeah. So, well, on the exam, Professor Chyn said that we would be getting a function, and then we have to interpret the function to see if it's recursive, for example, like if it's 2 plus t of n over 2 plus n squared or something like that.
right, okay.
And then like analyze
Mhm.
recursively using like a tree, something like that. So the only thing that kind of trips me up is still the use of logarithm in that when you're analyzing it. I feel like I get a little stuck towards the end.
So for the you mean the binary search question at the very end?
Yeah, yeah, stuff that's like similar to that. So whether or not it's a binary search or if it's like a sort or something like that.
Okay, let me screenshot.
Yeah, in the meantime, if anyone has any other questions, just make sure to write them in the chat. So we'll get a queue of questions. So we can get through as efficiently as possible. Thank you.
So for the binary, do you want to go over the binary this one or do you want to go to the next one right here?
Yeah, I guess either of them is fine. Uh, I think when we're doing the tree, I guess like analyzing it in terms of log. So she's done this where the tree, I guess, starts with whatever the n value is after the recursive part of the function. Like so in this case it would be plus two. In another question it was n squared, but in whatever it is, um yeah, just kind of like formatting the tree, yeah, like that. And then finding the answer for the second to last row with log, like I've been getting that wrong, and it's kind of hard to like, kind of picture it, I guess, as to why it should be in this case like 2 times 2 to the n, 2 times 2 to the log base 2 of n and stuff like that.
Um, Kevin, have you went over this before ever in the 220?
Sorry, Luis, your mic was cutting off. I heard
Have
just
you ever went over this the 220?
yeah, I can help out if you'd like.
Yeah, can you please? My bad.
Yeah, sure. Um, let's find the max minimum of the sequence. Okay, I think we have our general case. So for T of n, 1 second. So we start at the top, layer 0 plus 2. Could you maybe slide to the slide before this? Just need some context behind what's going on here.
Where
Yeah. Just give me 1 second. Yeah. Divide and conquer recurrent solutions. Find the maximum of the sequence. Can you go back again?
yeah,
Okay, great. Yeah. Max min. Okay, return max min. Okay. So start with this function here, right? So return max, max1, max2, and min1 and min2. Maximum minimum of the sequence. 1 equals 1 equals 2. Okay, so to interpret, let's say the first line where it says t of 1 equals 1, that just means that if our input is 1, we just get one operation, right? So t of n equals twice of t of n over 2. So you're basically dividing your search space in half, right? So your function is going to be taking in half the search space, which is what's going on here, right? So you're dividing it into 2 sections. And then the +2 that you have on the right, that's just like a constant it's a constant operation.
yeah. From what I recall, the +2 is like the operation of like for like binary search, right? +2 is the operation of finding the median and comparing the median, the target value. So it might be like different operation for here as well.
Yeah, maybe it would help just to look at a programmed example so we can walk through that. If there's any code anywhere, because that would be more helpful. Maybe the algorithm. Yeah. But I'm not sure if this was Joseph's question. Well, your question, Joseph, was related to understanding recurrence relations from code, right? So going through the code and then deriving the recurrence relation. But this doesn't actually have a recurrence relation, actually. It just has basic runtime. Is there another algorithm we can look over that has a recurrence going on?
Currents.
Aside from,
There's the binary switch, I think.
yeah. Well,
This one.
okay. Yeah, I guess we can start with binary search and then go down, right? Okay, so what's going on in binary search, right? So the idea is you start with some sorted list and then you divide it in 2 halves, which is what you're going, which is why you have t of n equals 2 plus t of n over 2, right? Your t of n basically gives you the number of operations you're committing to, right? So you start with your sorted list. You determine if the middle element or the middle index equals to the thing you're looking for, the number you're looking for. If it's not, then you're going to have to divide accordingly to 2 conditions, right? So here, the 3 conditions are provided. So C1 is if equals return index. So I'm assuming that just means if your value is equal to the thing you're looking for. So let's say we're looking for 12, then we just return the index of 12, right? Otherwise, if C2 is condition 2. I believe that's what it is. Yeah, otherwise, if the middle element is greater than the target, then that means we're gonna have to search on the left side. So we divide it in half, and then we just look at everything from, let's say, if we were at 12, and then we were looking for 8, for example, right? The median is greater than 8. So that means we'll need to search on the left half. So that'll be from everything between 3, 5, 6, 8, 9, 11. And we apply binary search there. Yeah, I think it'd be best if we actually drew this out as opposed to just describing it. So
Yeah. So you want to like a array, right? say a size 5, right? But let's give some numbers like say 2, 5, 8, 20, and 22. The first operation you have to do is find the median. So you have to find the middle value. In this case, it'll be 3. So you have 3. Next operation you have to do is do a compare to see whether or not 8, 8 would be our target value. If it's less than, you search this side of the array. If it's greater than, you search to the other side of the array. So essentially, from what I think, right, you're performing two operations where you have to first find the middle index of the median of the array. That's the first operation. And the second operation is the comparison of whether it's equal to, less than, or greater than. And then from that, you have to divide. And this would be the recursive part where within that, you'd have to find the median again for either side, depending on if it's greater than or less than or equal to. Are you feeling okay with this part or no? Would you want me, you want me to go over it?
Yeah, setting up the equation makes more sense now because I was wondering where the 2 was from, but that's just like finding the median and then doing a comparison. So that's the 2, right?
Yeah, the two is from like the two operations like right here. Find the median and
Okay.
then compare the median target.
Yeah, all right. I guess I overlooked that. So all right, so that's good. And
Yeah,
then finding this recursively, like then you just plug in n over 2 into n, and
yeah, because
that's where you get the n over 4 for the next part.
essentially, let's say you have an n size array, right? And once you finish these two operations, you're basically cutting this array in half, and depending on if it's greater than or less than, you either take care of this other half or this other half, which is why you divide it by 2. You would just keep on going until like you find your um target.
Okay, and can we go to the next slide also? Because then finding
This
like
one?
getting the 2, yeah, yeah. So for getting 2 times log base 2 of n plus 1 plus t of 0, which is equal to 1. Uh, I'm kind of trying to see because I know that she says that a pattern kind of emergence here where we have 2 squared and then 2 cubed and then 2 to the fourth. So I guess my confusion is a little bit like how to use log in this situation because normally I think of log in terms of exponentiation and not like dividing or multiplying by fractions.
See, in this part, right here.
Yeah, yeah.
So what she's doing is that she's making it equal to 1, and the one it's like one variable they want to single out is n. No, it's k. It's k. Oh, bad. You move 2k to the side, the other side to k. And if you apply log base log 2 on each side, log base 2 of 2k would just be 1. Then you have k out the outside. K, k. You want me to do like this part, this like small part? Is it? I could do this like small part if you'd like, if it's a bit confusing.
Well, I can kind of see like why like you said, you take log base 2 of both sides, and then, log base 2 of n would equal k times log base 2 of 2, which is 1, so that's just k. But then she plugs it back in and gets 2 times log base 2 of n plus 1, so I'm not sure why it's n plus 1 in that situation. Because if we set k equal to log base 2 of n, um,
Oh, wait.
yeah.
The only thing I can think of right is she's making n k equal to 1. To 1. I'm not entirely sure why she added plus 1.
Well, I think like if k equals log base 2 to the n, then k plus 1 equals log base 2 to the n plus 1. So I guess she's doing this k plus 1 times instead of k times.
So
Uh,
you're saying it's like 2k plus 1.
yeah, I'm just not sure why it's k plus 1. I mean, I guess I can go back and look at her recording to be sure.
Yeah,
But yeah.
yeah. Hold on. Is there any other question you want to go over?
It was mostly doing this and doing the tree and stuff, but I can go over that too with the recording. I don't want to take up too much time.
Okay, that's fine. Not bad. Is there any other topic which you guys want to go over? Any other question? Are you guys okay with second and first um second homogeneous questions? Linear homogeneous? That's something you guys want me to go over? Yeah. Hold on. Delete the slides already. Um, is there a specific one you guys want me to go over, or should I just start from the beginning? So
The exam is just going to cover second order linear or also first order.
first order linear, she mentioned how I think she said that like it cover also first order as well. If it's something you guys want me to go over as well. See. Do you want me to go? You guys want me to go over? Um, right, first order recurrence relation. I'm pretty sure the exam might cover. There. Okay, let me start from here. Zero. Zero. So you have this first order recurrence relation. So let's say you have let's see. So you want to find the equation for this. So you have an equals to an minus one. So then you could just make this to an minus 1 equal to 2 to the an minus 2. So you could just sum this up. You could substitute this. So it could be 2 to an minus 2. This is essentially your an minus 1, but just written in this format right here. So, so then you just keep on going. Simplify it to 2. It's going to be an minus 2. You can keep on substituting this for an equal to 2 to the 2 times 2 a n minus 3. Essentially, this is again an minus 2. Simplify it to an equals to 2 to the 3 an minus 3. And as you keep going down, you can see that 2 to the 3 and an minus 3, it keeps on going down lower and lower. Eventually, you're going to keep on going until you reach the base case. So until an equals 2 to the k minus an minus k. Our k is going to have to be the same as n in order for it to reach the base case, because n minus n would just be 0. So a n minus n would be a 0. And since you want our n or k to equal n, you'd have 2 to the n top an equals 0. We know that a0 is the base case, so it should be an equals 2 to the n times 1. And that's essentially shape for this one. We keep going then. So for this case, our an equals to an minus 1 plus 2. Again, you have this a n minus 1 plus 2. You could again substitute this for an minus 2 plus 2 a plus a to the n. Simplify this, you get an equals to an minus 2 plus 2 times 2. It's like saying x plus x equals to 2x. Keep on going until an equals an minus 3 plus 2 plus 2 times 2. And then you just keep on going until you hit some n minus k plus 2 to the k. And for this case, you want um, n minus k to be 0. So our k would have to be equal to n. an equals to an minus n plus 2 to the n. N minus n would just give you 0. So it'd be an equals a 0 plus 2 to the n. In this case, our a a0 is 1. To be equal to 1 plus 2 to the n. Yeah, to the n. Do you guys have any other any specific questions you guys would like to go over?
Can you do one like finding the runtimes of the recursive functions, like a whole function?
One for the like the binary search.
I don't think it's like a specific one. I guess that one's fine. Yeah.
Okay, so for the binary search, what you're doing is you have an array. The way the search works is that you first check the median value of the array and check if it equals to the target that you're looking for. If it's equal to, then you found your value. If it's less, if it's more than your target, meaning that it means that your target is in the lower range of the array. If you're no, wait, it's not the other way around. Yeah, if the middle element of the array is greater than the target, you would have to search the left side, so like the lower values of the array. And if the median value of the array is less than the target value, then the target value has to be in the upper half of the array. So the first two operations are find the median and compare the median with the target. Those are two operations that you have to have. So 2 plus the recursive part, which is you have to cut this array in half and then search again. So here she goes over it. T n 2 plus T n divided by 2. You keep on using this n, keep on dividing by 2, and you keep on going down further and further up until you start seeing a pattern of 2k plus T n divided by 2k. You set it equal to 1 and try to find what k equals to. So in this case, k equal to log 2 to the n. Put it here, log 2 to the n plus 1, and then plus t 0, which is just 1. Is there anything else you want to go over? Any other topic you want to go over? Are you guys okay with probability? Would you guys want me to go over some probability questions? Like base theorem and such.
I gotta head out, but thanks for your help, guys.
Yeah, no problem.
Yeah, of course.
Does anyone have any other question on any topic you guys went over? Maybe probability, counting questions, maybe more recursion.
I came kind of late, so I don't know if you already went over it. But in the list of questions, she mentioned that there would be a closed form definition question, as well as a recursive definition one. Do you mind showing me one of those? I came in kind of late though, if you already went over it.
Definition. Like the definition of recursion.
No, like, what's it called? Like, you know how if she gives you the equation, I guess, for a sequence, what's the definition of the sequence with the t in it, and then the closed form is the one without the t. If that makes sense.
Oh, is it any of this that you're talking about? Or was it in the lecture?
Yeah, I think it was those. That's what I came in on you guys doing.
Yeah.
Okay.
You want me to go over this?
Can you go over a different question, please?
Oh, one of these, right?
Yeah, thank you.
Yeah. Let's see. Okay. So for here, right? The A0 equals to 2. And you have A1 equals to 7. AN equals to, wait, yeah, AN equals to AN minus 1 plus, my bad, the handwriting, AN minus 2. Okay, so we have A0 and A1 as their base cases, like 2 and 7. And AN is the recursive equation. What you want to do is make every AN equal to Rn. So you have, instead of like all this AN minus 1 and AN minus 2, it'd be Rn equals to Rn minus 1 plus 2 times Rn minus 2. And what you would do is divide by the um least exponent. In this case, it would be Rn minus 2. Put this both sides. Let's do this. Rn minus 2. Here it would be Rn minus 2. Here would be Rn minus 2. So these ones would divide out. This one would just leave you with a single R. and this one would just leave you with r squared. So it would, in the end, it would be r squared. R squared equals to r plus plus 2. You want to move everything to the left, so it'd be r squared minus r minus 2 equal to 0. And then you want to find the roots of this polynomial. The roots would be r plus 1 and r minus 2. Equals to 0. So right here you have your two roots. You have your first r1 equal to -1, and your second r2 equal to 2. And from there, depending on whether these two roots are the same or they're different, if they are the same, you'd have um yeah, this equation where it's time an equals to alpha 1 times your r1 to the n, plus alpha 2 and your r2 to the n. And this is the case if they were both different roots. If they are the same root, then you'd use yeah, right here. In the end, these two roots are the same. So instead of like the typical alpha rn r1n plus alpha 2 r2n, it would be alpha 1 times your r1 to the n plus alpha 2 times n times your root again to the n. So essentially, all you're doing is just multiplying an n on this side. So that's the case if they were the same root, but they're not. This question. So we're just gonna use this one, and the equation is an equals to alpha 1 r1 r1 to the n plus alpha 2 r2 to the n. So we have our r1 and r2, and it would be an equals to alpha 1 times -1 to the n plus alpha 2 times 2 to the n. Uh, yeah. And now you're you're gonna want to use our base cases from earlier. Like right here, you have a0 equals to 2, a1 equals to 7. So let's do that. So let's say if a0 was equal to, if an is actually a0, so that would be 2 equals to alpha 1 -1 to the 0 plus alpha 2 2 to the 0 to the 0. This would come to alpha 1 plus alpha 2 plus alpha 2. So that's one of the equations. Now you want to do the A1. So you put it to 7 equals to alpha 1, 1, -1 to the 1 power to the 1 plus alpha 2 to the first power. This would come to 7 equals negative alpha 1 plus 2 alpha 2. Now that you have that now that you have these two equations, you have 2 equals to alpha 1 plus alpha 2. 7 equals to negative alpha 1 plus 2 alpha 2. If you add these two together, alpha 1 and alpha -1 would cancel out. 7 plus 2 would equal to 9. This would be 3 alpha 2. Divided by 3 is alpha 2 in this case would be 3. Yeah. And then you can just plug in alpha 2 into this. So 2 equals to alpha 1 plus 3, 1 alpha 1. And now you have everything you need for the equation. So now that you know what alpha 1 and alpha 2 are, you can write it out. So instead of an equals to alpha 1 r1 to the n plus alpha 2 r2 to the n, you have everything you need. So you'd write an equals to alpha 1, which is just -1, -1, then r1, which is also -1, -1 to the n plus alpha 2, which is 3, then 2 to the n. That's your -1. You just want me to go over another one? One where like it equals to each other? Or like when the roots are the same? You want me to go over any other question? Or do you just want to continue this with a different problem? guess I'll go over another case of the same one, but like when they're both equal to each other. So we have a0 equals to 1 and a1 equals 6. 6 and an equals to 6. An minus 1 minus 9 an minus 2. So again, you want to make your an equals to rn. So you have the equation r. You want to have rn equals to 6 rn minus 1 minus 9 rn minus 2. Again, you want to divide out by the lowest exponent. So you want to divide out by rn minus 2, rn minus 2, then rn minus 2. These two will just divide out. This one will just leave 1r left. So we leave 2r. R squared equals to 6r minus 9. Move everything to the left. So it'll be r squared equals to, actually no, hold on. R squared equals r squared minus 6r plus 9 equals to 0. We want to find the roots. In this case, it would be r minus 3 minus 3 r minus 3 equal to 0. So the only r's we have are 3. They're both the same root, so instead we'd be using an equals to alpha 1 rn r1n plus alpha 2 times times n times r2n. So we have that. We have the roots, so let's do this. Let's use the base case where a0 equals 1. So here this would be 1 equals to alpha 1 r1n. R1 is 3 to the n plus alpha 2 times 0, because in this case, because we have the base case a0, so our n would be 0. 0 times, wait, this should also be 0, but times a130 plus alpha 2 times 0 times 3 to the 0. And you multiply the 0, just all go to 0. And this will be equal to alpha 1. 3 to any power, anything to the 0 is just 1. So our alpha 1 would just be 1. Now that we have that, we can just do the other one where n equals 1. So it'd be 6 equals to alpha 1, which we know is 1, times 3 to the 1, because our n is 1 in this case. Here n would be 0, here n would be 1. Again, plus alpha 2, we don't know what alpha 2 is yet, times 1 times 3 to the 1. This would just come to 6 equals 3 plus 3 alpha 2. Subtract by 3 both sides. Be 3 equals to 3 alpha 2. Divided by 3 by both sides, you'd get 1 equals alpha 2. So now you have everything. Have the root and alpha 1 and alpha 2. Then you could just write it out. Our answer would be an equals to alpha 1, which is just 1, times r1, which is 3 to the n, plus alpha 2, which is also 1, times n, times root 2 to the n power, which is 3n. The end, this would all be an equals 3n plus 3n. That's it. That would be your answer. Is there any other question you guys want to go over?
If no one else has a question, can you do like the ball ones where like you have colored balls and each box has a different
Okay.
probability?
Yeah, sure. Let's see. Let me find it real quick. Is it probability or counting review?
Sorry?
Is it probability or counting review
Um,
for the ball one?
I think that's considered counting. I'm not 100% sure.
Okay, let me find it. Is it this one? Let's see. Is it this one you're talking about?
Mm,
With the 50 balls, 1 through 5, 1 through 50?
yeah, I mean, that one I'm sure will be on there too. It's the one, I don't have the wording in my notes. Honestly, it's the independence one, so that it's like
Oh, independence.
you have three boxes with different color balls
Oh,
in
yeah.
them.
I think it's somewhere.
And it looks like a paragraph. She wrote it out as a paragraph. Oh, those ones. Yeah, that the base theorem one.
Oh, base theorem. Okay,
Mm-hmm. Yeah, thank you.
no problem. Yeah. So let's see. Wait, this box. It's two green balls, seven red ball, four green. Okay. We draw two boxes. First one contains two green and seven red. Seven red. Second contains four green and green, three red. Bob selects a ball from the first, choosing one of the two boxes at random. Bob selects a red. Okay, so in this case, right, the events that lead on to getting a ball, right, a colored ball, right, there's two events. The event where he picks one of the two boxes to pick out of, and then the second event where he picks up a random ball from that box. So let's make up two events. Okay, okay, so let's make up B1, right? B1, a better bit. B1 is the event that Bob, let me type that. So B1 is the event chooses box one, right? So that's B1. And then there's a second event where if he gets a red ball, so red picks up a red ball. So those are the two events. Okay. So the probability, let's say, the probability of picking box one is, yeah, B1 of the event of that happening is one half because there's only two options. There's either the first box or the second box. And then there's this probability of B1, which is in the event that he chooses box 1. And then there's the complement of that where P B2 equals to 1/2. This is the probability that he chooses box 2 instead. It's 1/2. They're the same. They're the same probability. And so if he chooses box 1, right, the probability of getting a red ball is 7 over 9, right? Since there's a total of 9 balls and seven of them are red. So you could write that as probability of um, red, given that he chooses box 1, which equals to 7/9. And then there's also the case that chooses box 2 and he chooses box 2 and gets a red ball from that one. So in this case, it will be red B2 equals to it's a total of 3 red balls out of 7. So it would be red of 7. Now that you have all this, what the question is asking is that if Bob selects a red ball, what is the probability that he will select a ball from the first box? He selected a ball from the first box. This means that if he gets a red ball, what is the probability that he got it originally he chose the first box? So what this saying is that probability of B1 given R, meaning that he got a red ball, what is the probability that he got from box 1 is what we're trying to find. Similar to here, we were given that box 1 was chosen first, and so then we just figured out what's the ratio of like what's the probability of getting a red ball from this box. Here we were given B2, so what's the probability of getting a red ball from this box? But now we're given this one where we have a red where we're given a red ball with the probability that we chose it from box 1. And she mentioned there's this formula where P B1, let's write it out instead. P B1 given R is equal to the probability of B1 intersection R divided by probability of R. So let me write it better. Section R over the probability of R. So we have this equation. So this top equation, right? The probability of B1 intersection R. This equation can equal to two things. It could either equal to the probability of probability of B1 times the probability of R given B1, or it could mean the probability of R times probability of B1 given R. So essentially, like they're two swaps. It's either B1 comes first and then the next one R comes first and then B1, or R comes first and then B1 comes next and then R. So this top can be split into either of these two, depending, and you choose which one depending on what you have so far. So in this case, we wouldn't choose PR times PB1 over R because we don't know what R is yet. We only know what B1 is and R given B1 is. So we choose probability of probability of B1 times probability of R given B1, and then the bottom we have PR. We know what PB1 is, so we could make that into 1/2, and we know what PR given B1 is, which is we got here earlier. So it would be 7/9, 7/9. And now all that's left is to find what PR is. Okay. PR so what PR is equal to, right, is the whole everything that's in R intersects P no, actually what R equals to is R intersection of B1 union B2. I'll show you how how we get to this. Because essentially, I think that when we say this, right, we're saying that the only two like boxes for the sample space is B1 and B2. And you know there's like some greens in here too. There's a collection of red balls that are like both aren't together right here. So if this is our R, this whole space, if we intersect R with B1 and B2, we'd get the whole R inside the space, which is equal to R. And the other ones would be like green on the outside. So here we could put this out into R intersection B1 union R intersection B2. We have this, which is basically the same thing as this, because R intersecting B1 would just be this spot right here, this spot. Then R intersecting B2 would just be this spot inside here. So this would give us all of R, which is here. It's like a giant pill. So we'd get next we could do the probability of R, which equals to the probability of R equals to wait, uh, it would be the probability of R, equals to the probability of R intersect B1 plus, because you just plus probability of R R intersect no R intersect B B2, B2, yeah. So then you get this, which is what your professor showed right here. And then from here, you can you can recall that this kind of intersection can be split into either of these two. So with that, you can write you get P of R equals to probability of, depending on which one we have, we'd use, in this case we'd use B1. So probability of, let me erase this. In this case we have probability of R equals to probability of B1 times the probability of R, probability of B1 times probability of R given B1 plus and then you have this one, depending on which one you want to use, based on what you have. This one would be probability of B2 times probability of R given B2. You have everything you need here. You have everything that you have. Like all the stuff you need is right here. So just plug in. So this would be PR equals to probability of choosing box one, which is 1/2 times probability of R given B1, which is 7/9, plus probability of B2 picking box two, which is 1/2, times probability of getting a red ball from box two, which is 3/7. In the end, you're in the end it would be like, so I mean now you know your PR, right? But you have the rest of the stuff. So all you need now is just plug in PR, whatever it is. So this would equal to 1/2 times 7/9, and then the rest of it. So it'd be 1/2 times 7/9 plus 1/2 times, wait, 1/2 times 3/7. I think it's uh, 3/7. Yeah. So this would be your final answer. Is it are you confused in any spot? Or do you want me to go over like any specific part that like is kind of confusing? Or is it fine? Is there any other question you want to go over? Is there any other question you want to go over? I mean, so far, did this make sense? Everything I went through. Is it good? Okay. Is there any other questions you want to go over? Or any other topic? Like maybe based another one based theorem or a different probability choice or counting review or recursion.
Would you do an expected one?
Expected?
Yeah.
Okay. Screen share. Okay. So, the value. Essentially, all you'll be doing is just multiplying the number of times you do it by the times the probability of the success. So in this case, you won the heads. The probability of that being a coin is 1/2. You do it 100 times, so it's 150. Same thing here. Flipping a head is 25, so it's a biased coin. Then if you want to flip it 100 times, and what do you expect is 100 times the probability of that, so it'd be 40. So what expected values are is the sum of probabilities of that specific x times xs. So this means that it's the whole sum, and here, guys. So let's go over this one. The expected value is x equal to 2. sum of every S in the sample space, every element in the sample space, their probability times that S. So here, right, the number that comes up when a fair die is rolled, what is the expected value of X? So when you roll a dice, all the possibilities of X are 1, 2, 3, 4, 5, 6, right? And each of the probabilities of X, each of the probabilities. So getting a 1 in a dice is 1 over 6. Getting a 2 in, the dice roll is 1 over 6. 1 over 6. Same with 3, 1 over 6. Same with 4, 1 over 6. 5, 1 over 6. And 6 is 1 over 6 as well. So all the probabilities, so we have the list of all the probabilities and x's. So what it's saying is that for every x, you want to do the sum of the probability, which is, let's go over this one. So the first sum is when x equals 1, so it would be 1 over 6, 1 over 6, 1 over 6 times 1, because that's the probability times the actual x. The sum of that with 1 over 6 times 2, because now we're in the second part, times 2, plus the probability of 3, getting a 3, over 6 times 3, which is what our x is in this case, plus probability of getting a 4, which is 1/6, times 4, times 1 over 6, and just keep on going, 5, plus 1 over 6 times 6. So here, all you're doing is just having all the probabilities times their actual value and summing all those together. X would be all the possible outcomes of the event. So like rolling a dice would the only numbers you could get when rolling a dice is 1 through 6. Here further down, it would be flipping a coin 3 times. And what's the probability of so 3 times outcomes. So in this case, it would be the number of heads you get out of the 3 times you flip a coin. So let's say you get no heads. That would be when x equals 0. So when there's no heads, then there's the chance of you getting a 1 head out of the 3 flips, which is 1 and 2 and 3. And then you would list all the probabilities of each one. Then again, you just multiply the x times the probability of that x, which is 0 times 1 over 8, 1 times 3 over 8, 2 times 3 over 8, and 3 times 1 over 8. Then add them all together like this. 12 over 8 would be equal to 1.5. That would be your answer. Yeah, I don't think there's any other. Here you just add the sum of the previous question, the previous answer. Because when you roll two dice, we did this before with pair dice. What we got was 3.5. So since there are two dice, you just have two of them. 3.5 plus 3.5 is equal to 7. And that would be it. Is there any other question you guys want to go over? Did it make sense so far? Is there any other question you guys want to go over?
You said that there was going to be either a dice, coin, or poker question. So can we do a poker one?
Poker. This one, right?
Yeah, something like that.
Yeah. So what is the probability that a poker hand, 5 cards, 5 cards, contains a full house? That is 3 of the same kind, 3 of one kind, 2 of another. Yeah. So with this question, with this problem, you want to have uh, so by one kind they mean of like the same symbol or number. So like Joker, 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 or Queen, 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 King, 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 7, 7, 7, 3, 3, 3, that kind of stuff. So the number of choices you have to have a copy of 3 cards of that same of that same symbol is 13. Because you have king, you have the choice of having a copies of king, copy of queen, a copy of joker, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Total will be 13. So for 3 of the same card, three of the same card. So for 3, like I said, there's 13 options, and you want to pick 3 out of those 4 options, right? I mean, so there's 13 options. Once you pick your option, there are 4 choices. There's total of 4 cards that to pick from, and you want 3 of them, right? So it would be a choose. So it would be 13 because there's 13 choices times 4, choose 3 because essentially, yeah, but I said you have 4 cards here, and you only want to pick 3 of the same kind. So once that's done, now you want to have 2 of the same card as well. So same deal, right? You look through all 13, right? Except for one, because that from the 3 cards, you already used up 3 of them. So you can't have 2 copies of that card. So you'd have 12 choices because you're excluding that one, that one pair or the one triple card that you got, 3 cards. So you'd have 12 options instead. And then from that, you'd want to choose, then there'd be 4 cards, and you want to choose 2. So it'd be 4, choose 2. Essentially, since these 2 are in the same 5 cards, you multiply these 2, it'd be 13 times 4 times 12 times 6. And so this would be your top. The bottom would be bottom would be if you choose 5, because you want to pick 5 cards. The bottom would be all possibilities, so you want to choose 5 cards out of all the possible cards. So it'd be 13 times 4 times 12 times 6 over 52, choose 5. Do you have any questions or no? Or any confusion? Is there any other question you guys want to go over? I bet it was a bit confusing for this one. Like I can explain it much better. This one, all you're doing is just like looking all through all 13 possibilities, choosing 3 of those, like right here, and then you have this case done, the 3 of kind, and you want to do 2 of a kind. So you can't pick this row anymore because you already picked 3 of those and there's not 2 left. So you have to choose between this, these 12, then choose 2 again. But is there any other question to go over? Uh, I remember you mentioned you want to go over another one, the different one. that she mentioned that was going to be on the exam? We have time for one more question. Do you guys have any like last questions? I think.
If you're okay with it, could you do another closed formula one, like one of the last ones that were kind of like harder to figure out the two root ones?
The one with an and an minus one, an minus two. That one.
Yeah, that's the only one that I'm like really not confident in.
Okay, that's true. Okay. Um, you were here for the this one, right? Like the first one, I think.
Yeah, I was.
Okay. So you want to go over this one? Like which like what specific part of it are you confused on, or just like in general? You mean?
Oh, yeah, we could do that one because I don't know if I'd be able the quadratic equation ones.
Okay, yeah, sure. Gotcha.
Okay, yeah.
Okay. So in this case, you have a1. I mean, you could just always use the quadratic equation like in general. Pretty sure for like all of them. But if you see like a solution right off the bat, then you can just use that as well. So you have a1. Yeah, you have you have a0 equals to 0. A1 equals to 1. Then you have an you have an equals to an minus 1 plus an minus 2. It's like that, right? A0 equals 1, a1 equals 1, an. So this would be our base cases. We do the typical part where an equals to rn. So everything here we have rn equals to rn minus 1 plus rn minus 2. You divide out by r with the lowest exponent. So in this case, it would be Rn minus 2. So Rn minus 2 divided by Rn minus 2, Rn divided by Rn minus 2. So you have this. This we cancel out. We divide out, and then Rn minus 2, my bad. Minus 2 minus 2. This would give you r to the 2 equals 2. R to the r, it's just r itself, and then plus 1. Move everything to the left again. So r squared minus r minus 1 equals to 0. Just like visually alone, you can't think of a solution for this. So you'd have to use the quadratic equation, which is 2r negative b plus or minus square root of b squared minus 4ac and 2a divided by 2a. Here our a is 1, our b is -1, and our c is also -1. Yeah. So we just plug in everything. So it would be r equals to negative b, which is actually, so our a in this case would be 1, our b would be -1, and then our c would be also -1, given from this. Then you just want to plug in everything. So negative b, which is -1, which is just 1, plus or minus b again, b squared, which is just 1, minus 4ac, 1 times -1 is just -1, times -4 is plus 4, and 2a, which a is just 1, so it's just 2. R equals to 1 plus or minus square root of 5 divided by 2. So this means that we have our R1, in this case, our R1 would be 1 plus square root of 5 divided by 2, and our R2 would be 1 minus square root of 5 over 2. Good so far? You guys good so far? Take it as a yes. So, and then you have R1 and R2. You see that they're not equal to each other. They have plus and minus. So, meaning that we're going to use the equation an equals alpha 1 r1 to the n plus alpha 2 r2 to the n. And here we have a n equals alpha 1 times r1, which is which is which is 1 1 plus square root of 5 by 2 to the n plus alpha 2 1 minus square root of 5 divided by 2 to the n. That's So now you have this. So then now you want to use our base case that we got earlier. So in this case, when n equals 0, it would be 0 equals to alpha 1, 1 plus square root of 5 divided by 2 to the 0 plus alpha 2, 1 minus square root of 5 minus, minus square root of 5 divided by 2 to the 0. Anything to the power of 0 is just 1. Then all you could have is alpha 1 plus alpha 2. You have that. Then you want to do the second base case, which when is n equals to 1. This would be 1 equals to alpha 1, and then it's called 1 plus square root of 5 divided by 2 to the 1 plus alpha 2, 1 minus square root of 5 by 2 to the 1. Okay, so I think what she does is, since we could change this up from, we could make, let's say, a2 equals to negative alpha 1. So knowing this, that h that no, that alpha 2 equals to negative alpha 1, we could just rewrite this as 1, write this as 1 equals to alpha 1, 1 plus square root of 5 squared minus alpha 1, 1 square root of 5 divided by 2. Oh wait, no. Wait. Okay. Right. Okay, so what she did right. Now that we have this equation, what she did was she multiplied this equation with alpha 1 plus alpha 2. She multiplied it with 1 plus square root of 5 divided by 2. Then you get 0 equals to 1 plus alpha 5, square root of 5 divided by alpha 1 plus alpha 2, 1 plus square root of 5 divided by 2, 2, and then she subtracted this with this. So subtracting 1 minus alpha 2 with this and this, these would cancel out. Still have 1 inside. 1 equals to alpha 2 times 1 minus square root of 5 divided by 2. 2 minus 1 plus square root of 5 divided by 2. This would equal to eraser. This would equal to 1 alpha 2, 2, 2, 2 divided by 5. These would cancel out, so then you get 1 equals alpha 2 negative square root of 5. Divide that, so that would be 1 divided by negative square root of 5 equal to alpha 2. That would be your alpha 2. You have alpha 1, so you have this equation from the previous. You could use this, so now that we know alpha 2, we can just use that. 0, 0 equals to alpha 2 equals plus alpha 1, wait, alpha 1 plus alpha 2, which is 1 minus square root of 5. Flip it over, you get 1 over square root of 5 equals to alpha 1. And then you just plug in these two with your roots to the equation. So it would be like it would be in the end it would be an equals to alpha 1, which is 1 square root of 5 times r1, which is 1 is 1 plus square root of 5 divided by 2 n power plus 1 negative square root of 5, 1 minus square root of 5 to the 2 to the end. That would be your answer at the end. Not bad. That's it for the question. All she did was just like find the use quadratic equation to find the root, find the roots, and then plug it in. That's everything, right? And I think it's all the time we have for the review.